Alright, so this is the second video of these notes. The other one got cut off accidentally. This page right here is just going to be a challenge page. It's pretty difficult, but just see how many of these you can get. Just remember they're right here, so automatically we know that D is going to be 50, okay, because those are vertical angles. And then just remember all of these, you've got vertical angles and you got linear pairs. So you're able to fill in a lot of those angles. You're trying to figure out what these angles are. Just remember, you know, this is a pentagon, so all 5 of these angles are going to add up to 5 minus 2 times 180. So see how many of these you can get. Pause the video real quick, see how many you can get, and then I will show the answers. Okay, so hopefully you've paused it. I'm going to show them. Okay, so those are your answers. You can check and see, so you can see that D is 50. Check and see if you got any of those right. But yeah, so we are moving on. If you didn't do great on this, it is okay. This is just kind of a challenge to see how well you know. Alright, last page of these notes. We've actually seen these at one point in the past, but we're going to be dealing with a lot of this over chapter 7, so we're going to go ahead and review you on it. This is just a reference right here, so just what it means to be a positive, negative, zero slope, that kind of thing. And then also undefined, which is also important. Okay? Then moving on, we've got parallel lines, perpendicular lines. These are important. Remember, this is the symbol for parallel. This is the symbol for perpendicular. We will be using those symbols a lot this chapter. Okay? And just what it means to be parallel, they have the same slope. And then for perpendicular, remember it's the opposite reciprocal. So opposite reciprocal. Okay, where you change the sign and flip the fraction. Let's move down here to distance formula. Okay, I know you've done this a lot in the past, but we will be doing it a lot this chapter, so here's just a little refresher. We got our x1 and our x2, so x1, y1, x2, y2. You're labeling your points. Now we can subtract -1 minus 5, and we'll square it. And then 9 minus 1, and we'll square it. So I just took my x's and subtracted them, my y's and subtracted them. Alright, now we've got -6 squared plus 8 squared. Any number squared is going to become positive. 36 plus 64, not -36. That will make you get it wrong. It's going to be the square root of 100. So we'll get 10. Great. Alright, and then this one is a little more difficult. You want to find the distance between these 2 points. So there's our x1, our y1, our x2, and our y2. So 5 minus -3. Remember what happens there. You end up adding it. Squared. Alright, and then 2 minus 4 squared. Got 8 squared and 2 squared. Well, technically -2 squared, but it'll end up being positive. So 64 plus 4. Now we've got this square root of 68. That can be simplified. We don't want decimals. We want to know that 4 and 17 go into 68. So it becomes 2 root 17. Okay, that was a pretty quick crash course, but we've done this a lot before. So you can rewind it if you have any questions. Okay. Here we go. Find the distance / length of all 4 sides. We're going to be doing this a lot. This chapter you're going to take a polygon and then have to figure out how to find the distance. So For AB, it's pretty nice. You don't have to use distance formula. You could just count, which that's good. So you can count and know that it's 9 units from A to B. 1, 2, 3, 4, 5, 6, 7, 8, 9. From D to C, you can count. It's 9 units. So that's nice. Alright. So we know that AB is congruent to CD. Alright, now we've got BC and AD. You can either use distance formula, or, since we just did that on the one before, I'll show you how to use Pythagorean theorem, which we have done before this year. So if I'm looking for this AD, which is the hypotenuse, I draw a right triangle. So from AD it goes up 5 and over 2. 2 squared plus 5 squared equals C squared. So very similar to the distance formula. Alright. So now it's 4 plus 25 equals C squared. So square root, oh I wrote it on the wrong one. But square root of 29 is what AD is going to be. And then it's also BC because if you notice, it's the same triangle, 2 and 5. So you do that over again and you get the square root of 29. Can't simplify 29. None of the perfect squares go into 29, so you just leave it. But we can write that BC is congruent to DA or AD. Doesn't matter, they can be flipped. And voila, we'll be using this a lot this chapter. So just make sure you know what's going on.